Lesson 10-2, Simplifying Radical Expressions. In this video, you will learn to simplify radical expressions by using the product property of square roots, and also simplify radical expressions by using the quotient property of square roots. Your vocabulary for this section is radical expression, rationalizing the denominator, and conjugate. So, first thing we're going to look at is the product property of square roots. For any non-negative real numbers a and b, the square root of a times b is equal to the square root of a times the square root of b. Or that's to say, if you have multiplication inside of a square root, you can break it up and have it the square root of one thing times the square root of the other thing. The square root applies to both things. For example, the square root of 4 times 9 is the same thing as 36 or 6. And you can think of that as the same thing as the square root of 4 times the square root of 9, which is 2 times 3, and you still get 6. So if we're looking at something like this and we want to simplify it, we're looking for any perfect squares that go evenly into 52, because 52 itself is not a perfect square. So if we think of our perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 49, 64, 81, 100. And we can just start with these. So we're looking to see if any of these go evenly into 52. The only one that you can divide evenly into 52 is going to be 4. So 4 is going to be a number we want to use. So 4 times what is 52? 4 times 13 is the same thing as 52. So I can rewrite 52 as being 4 times 13. And then the product property says that I can say that's the same thing as the square root of 4 times the square root of 13. Now I know the square root of 4 is 2, but 13 is a prime number, so there's no other number that would go into this. So this is going to be my final answer. Okay? And that is now simplified. So a number or an expression that has a square root is simplified when the number inside the square root can no longer be, there's no more perfect squares that go evenly into it, and it's not in the denominator. We'll talk about that later, but you can't have a square root in the denominator of a fraction. So if I want to simplify this, sometimes it's helpful to multiply them together first and think of this as the square root of 48. You don't necessarily have to do it like that. You can simplify them both. But if we did this, it might make it easier. So again, I'm looking and thinking of what are the perfect squares that go evenly into 48. So into 48, 16 goes 3 times. So 16 is the biggest square root, perfect square that goes into 48. So I can think of this as the square root of 16 times the square root of 3. So this is going to be 4 square root 3. And that's as simplified as it goes. Okay. Had you been doing this another way, if you're looking at this, another option you could have said, okay, I know that the square root of 24 is going to be the same thing as the square root of 4 times the square root of 6. And then I have times the square root of 2. And then you could have said, okay, so this is going to be square root of 4 becomes 2, and then I have the square root of 2 times the square root of 6, which you can say is the square root of 12. Now you have 4 that goes evenly into this. You could say this is 2 times the square root of 4 times 3. So then you're going to get 2 square root 4 times square root 3. So you're going to get 2 times 2 times square root 3, and you're going to get 4 square root 3. Now, you can obviously get the same answer, but there's sometimes ways that are faster. So you want to be looking for those. Okay, when you're looking at this, we can again do the same thing where we apply that square root to each of the square root of 45 times the square root of a to the 4th times the square root of b to the 5th times the square root of c to the 6th. And then I want to simplify each of these as much as I can. So 45, again, I'm looking to see if there's any perfect squares that go evenly into it. So remember, those are 4, 1, 4, 9, 16, 25, etc. So 9 goes evenly into 45, and that's the same thing as 5 times the square root of 9. A squared, well, a to the 4th, I'm thinking, if I think about this as 2, what I can do is I can take this inside number and divide by this number. 4 divided by 2 is 2, so this is going to become a squared. The square root of a to the 4th is a squared, because a squared gives you a to the 4th. What happens if this doesn't divide evenly? So 5 into 2, it goes 2 times, but I have 1 left. So the leftover stays inside. So I can say b goes twice. I can take that out. It goes out to evenly 2 times. 2 into 5 goes evenly 2 times with 1 left over. So I have b to the 1st left inside. Okay? And then c, the last part, c, 6 divided by 3, that's going to go 3 times evenly. So that becomes c to the 3rd. Okay, so I just want to take any of the ones that have a square root left. 5 doesn't simplify anymore, and square root of b doesn't simplify anymore. But, however, square root of 9 is 3, so I'm going to have 3a squared, b squared, c cubed, and then what I have left inside the square roots, that 5 and the b, stay inside a square root together. And then that's the simplified form. If you can picture doing this without writing it out like this and going from here to like here, you could do that. It's just for practice and for time. Right now, just be used to doing it this way. Okay, the same applies with a quotient. So just like if you have multiplication inside of a square root and you can break it up, you can break up division too. So the square root of a over b is the same thing as square root of a divided by the square root of b. So I want to know which of these is equivalent. For this one, you have to know how to rationalize a denominator. So what I'm going to do, I want to get rid of the square root of 8. Like I said before, when you simplify, you can't have a denominator having a square root. So I want to get rid of it. So what I can do is I can multiply by itself to top and bottom, right? So if I do it to top and bottom, I'm not changing anything. So this becomes, on the top, 8 times 3n becomes the square root of 24n. And then on the bottom, it becomes the square root of 64, which we know the square root of 64 is 8. So on the top, I'm looking at 24, and I'm asking myself which perfect squares come out, and we can say 4. So I can say that's the same thing as the square root of 4 times the square root of 6n. So square root of 4 is 2, so we get 2 square root 6n over 8. Now 2 over 8 reduces. 8, I can think of that as 1/4, so this is going to become square root of 6n over 4. And so that means my answer is going to be D. Okay, if I want to simplify this one is not as easy to get rid of the denominator, because if I multiply this by square root 5, I'm going to end up having square root 5 and 4 when I multiply the bottom. So what I do is I multiply by something called the conjugate. And the conjugate, when you have a binomial, so 2 terms, what it does is it's the opposite with the sign in the middle. So if this is minus, the conjugate is going to be plus. So if I multiply top and bottom by the conjugate, so that's going to be 4 plus the square root of 5. So let's see what that looks like. So to the top, 4 plus the square root of 5, and also to the bottom, so it's like multiplying by 1. I haven't changed it. Okay, on the top, when I distribute that 2 in, I'm going to get 8 plus 2 square root 5. And on the bottom, this is like foiling now. This is a binomial times a binomial. So I'm going to do my first terms, which is 16. My outside terms is going to be plus 4 square root 5. My inside terms is going to be minus 4 square root 5. And my last terms, square root of 5 times the square root of 5 becomes 5. So it's going to be minus 5. And then I want to go through and simplify this. So on the top, there's not anything I could really do. I leave it as 8 plus 2 square root 5. But on the bottom, these terms, the middle terms, end up canceling each other out. So you have positive 4 square root 5 and negative 4 square root 5. 16 minus 5, or in our case, 11. So you get 8 plus 2 square root 5 over 11. And now there's nothing more you can do to this simplify because 11 doesn't go evenly into 8 or 2. If it went evenly into both, then you could reduce. Or if there's something that's common between all three numbers, but there's not. So we stop there. And that is lesson 10.2.